this episode, we're going to start working through how to write a player controller. So let's create a new C# script. We're going to call that player controller. And then we're going to open that script up and let Visual Studio load up for a second. Alright, we're going to need a few things for this script. So let's start by, we're going to remove our start method because we don't want to actually do anything on start, and we're going to swap to fixed update instead of update because we want everything to be happening at a fixed rate because we're going to be handling the physics of the players. Let's start by declaring some variables. Let's use a header. We haven't done this before, but you can go header, and then we put brackets, speech marks, and let's call this section movement. Now this will appear in Unity, so you'll be able to see that these are part of the movement. So let's get a public float, and we're going to call this move speed, and we're going to set it equal to 5F for default. Let's do another float. I'm going to call this jump force. We're going to set this equal to 5 as well to start off with. These can all be adjusted later. I'm going to have a public rigid body. And we're going to call that RB. And then we're going to have a bool. Let's actually make this public as well. Public bool is grounded. Is grounded. And we're going to set that to true by default. Okay. So this just means if you attach this script on, that these are going to be set to these settings by default, but obviously we're going to change them as we write the code. Okay, so in fix update, we're going to, let's not do it in, let's make our own methods for it. Let's write a move method, void move. Now void just means we don't return a value, we just simply run the code inside it. That's why you put the void. I did not want to make, we do not want it public. We just want void move. Okay, perfect. And let's call move from here. So each time fixed updates run, we're calling all the code in move. And then let's also go void jump. We'll come back and we'll also want to call jump constantly as well. Now you're thinking, oh, we don't want to move every frame. That's okay. We can still set our conditions for the movement inside of these methods, but we can call them each frame to check them. Alright, so in move we want some more variables. We're going to use a float. We're going to call it move x. I'm going to stick it to 0. And we're going to do the same for that, but we don't want y, we actually want move z. And then we're going to start writing some ifs. So we're going to go if input dot get key code, and then let's use w and brackets, and then we're going to go move z equals 1f. Okay, and then let's copy and paste this a few times to make it easier to write, because we're going to need 4 of these. And then we're going to go S, capital S, and then we're going to make it negative. And then for this one, we're going to go A, and we're going to go move X. Move X is equal to -1. What have I done wrong here? Why does it not like that? Why does it not like that? Let's just continue and we'll see move X. And then let's use D for here. I don't understand what's different here. Oh, I see what the issue is. We missed a bracket. Syntax is important. Okay, so we're setting our move X and move Z variables to equal either 1 or -1 on each of the key presses of WASD. So +1 for W, -1 for S for Z movement, and then -1 for A, +1 for D. Okay, then we're going to use these variables. So now we're going to go vector free. I'm going to declare a vector free and call it move direction. So these variables are being declared like these variables are being declared up here, but they're local variables. So these variables only exist within the method. So I couldn't adjust these from the jump script, these variables. You'd have to make a new variable for it. Whereas these variables are global and they exist throughout the script. So let's continue here, equals, and then we're going to set it to transform dot forward, so the forward direction of the player, and then we're going to multiply it by move X, and then we're going to add to it transform dot right, and then times it by move X. So we're looking at the forward direction and then multiplying it by our move Z variable. And then we're going to look at the transform to the right of the player and then multiply that by the move X. And that's going to return us a value that gives us a move direction. We're then going to create a new vector free called move. And we're going to set that to equal to move direction times move speed. Move speed. And then we're going to times that by time dot delta time. And that means true world time, 1 second to 1 second. You can use other times that are based on the time scale that you have, but that is 1 second equals 1 second, not affected by any adjustments to time scale that you've had. And then finally, we're going to go transform dot translate, and then we're going to use move, and then we're going to go space dot world space. Okay, so let's add some comments into this so we can So we're checking the inputs and we're setting these values based on the AD for horizontal, WS for Z. We are calculating the move direction. Applying the move based on the direction. And then we're applying the move to the holder of this script. So whatever's holding this script will have this moved because we didn't declare what it was. If you wanted to have this script held by something else, you would need a variable for the player game object, and then you would need to access its transform.position and then move it like that. See you in the next video.